Hello and welcome to the Daily Space. Today is August 7th, 2018, and I am your host, Dr. Pamela Gay. I am here to put science in your brain. I'm going to do a brief roundup of today's astronomy and space science news, and then I'll hang out and answer. I will answer your questions. Please go ahead and @ me in the chat if you have anything you want me to notice. So in today's first story, we have a tale of distant radio galaxies. Now, we detect different kinds of galaxies in different ways. Some systems are brightest in the kinds of light that we see with our eyeballs. Some galaxies are brightest in the kinds of light that we see in the ultraviolet. And some are brightest in the color of light that corresponds to what we detect with radio telescopes. The reasons that things are brightest in one color or another has a lot to do with what's going on in the black hole. Perhaps there's a ton of star formation that has a lot of those super blue stars just hanging out, giving off their ultraviolet light. In other cases, you might have a active galactic nuclei, a supermassive black hole with a disk of material spiraling around it, glowing brightly in all the different colors, and in its rotation generating a giant jet of material that gives off amazing amounts of energy in radio wavelengths. Well, we use different kinds of telescopes to detect these different things, and we see different things as we do it. In this particular image, what we have is, in the white contours, a contour map of, well, what was seen in the radio. And what is seen in the radio is always blobby and deserving of contour maps. Now, in looking at this object that was discovered using the Very Large Array, that was observed using the Very Large Array, it was discovered using a giant radio telescope in India. It was followed up with the Large Binocular Telescope and with the Gemini telescope. With Gemini, they used a spectrometer. And using this technology that spreads all the colors of light out into a rainbow, allowing us to see the specific colors the different atoms either emit light or absorb light, we're able to see, well, how those colors, how those fingerprints specific to different atoms appear shifted relative to some sort of a standard source. By looking at how this galaxy's specific wavelengths were shifted, I'm having bad finger day, were shifted relative to some other static source, they were able to figure out this galaxy is, well, now the record holder for the furthest away galaxy that's bright in the radio. It was found at a distance so great that the universe was only 7% of its current age when the light was emitted. We're talking over 12 billion light years away. Now, we don't really know that much more about this galaxy other than it's far and it's radio loud. I'm going to stay tuned along with the rest of you to see what more we learn about this object. Now, as more nations are building more larger and larger telescopes, we're going to be able to observe fainter and fainter sources. In dealing with radio telescopes, we have two different things that we have to worry about. What is the greatest distance between one edge and another edge? That gives us the resolution. Here, telescopes like the Very Large Array and the very long baseline interferometer always win on resolution because they're either desert sprawling or even continent sprawling in the case of VLBI. Now, although these systems give us amazing resolution, because the individual dishes are fairly small, we have to turn to these giant dishes in many cases to be able to see the most faint objects. So in looking for distance, we're also going to end up looking for faint. Well, bottom line, it takes every kind of telescope to find the furthest out object and the faintest objects. This one's going to be fun to follow. Now, going on to our next story, we have a tale of, well, invading debris from a asteroid. Or a comet in this case. What I'm talking about is the Perseid meteor shower that is going to occur on the night of August 12th-13th. So the night starts on the 12th, ends on the 13th. If you're in the northern hemisphere and you go out, well, around 11 p.m., assuming you're not in Arizona, which doesn't respond to daylight savings time, or in any of the other places that don't respond to daylight savings time. If you go out and look up, you will see massive numbers of shooting stars, meteors, just little bits of gravel and pebble-sized debris left over from the passage of Comet Swift-Tuttle. Now, the last time we saw Comet Swift-Tuttle was back in 1992. This means that while we've gone through the debris a couple of times, there's still a chance that there's going to be an amazing amount of debris for our atmosphere to collide with, bringing us an amazing show. This particular comet has an orbital period of about 133 years. We pass through its debris every August. This was the first big meteor shower I ever saw as a kid. The comet that produces this debris is in a kind of unique orbit. It's in a 1:11 resonance with Jupiter, which means that it goes around the sun once for every 11 times that Jupiter goes around. It's just kind of cool. It was one of the first objects that we were able to figure out all of these different connections with. And it's just a great excuse to go out on what is probably going to be a bug-filled summer evening. So put on your DEET, pull out a hammock, and go out and look up. I personally use this as an excuse to listen to podcasts and audiobooks out in my backyard, and just hope that the bugs stay away. So in our final story, we return to something that came up yesterday. We are getting second by second closer to the earliest possible launch of the Parker Solar Probe. Now, they have, doing a bunch of maths, extended the launch window. There will be another NASA media announcement about the launch window. But currently we're looking at, and here I have two different numbers I'm going to get you. The website that we're looking at is saying current launch window estimate August 11th, 2018 at 3:48 a.m. Eastern, which means I'm going to be getting online at 2 a.m. to bring you the launch countdown. Europe, this one's for you. Now, while the website says 3:48 a.m. Eastern, the press release that was issued this morning says 3:33 a.m. Since I don't know which it is, I'm going to start watching at 3 a.m. Eastern. 3 a.m. Eastern is 8 a.m. London, and I actually kind of like the Pacific time zone a little bit better. That 3 a.m. Eastern is going to be, well, midnight Pacific. So I hope to see you there. So this is where we're at. This is what we're planning on. And this has been today's big news for the Daily Space. Go ahead, start typing your questions in, just at me in the chat. While you're doing that, I'd like to remind you that, well, the Daily Space is brought to you as part of CosmoQuest. Check out CosmoQuest.org, where we invite you to do science. Our team scientists are currently working on data surrounding Mercury, and we hope to be producing science in December to release to all of you. Now, for our science to be successful, we need all the measurements you can make. So go and pull it open if you have a bit of screen real estate, and help us mark some craters and understand this world that is snuggled a bit too close to comfort up against the sun. The Daily Space and CosmoQuest are collaborations of multiple different institutions. Here on Twitch, you're going to see faces from the Astronomical Society of the Pacific, where I work, along with Big J. You'll also see Dr. Matt Richards, just not this week, or Dr. Matt Richardson, rather. You won't see him this week, though, because he's off at a conference. You also will see Annie Wilson here periodically, coming to us from Youngstown State University. Our next show on this channel will be tonight, where I'm going to be doing Astro Office Hours and continuing my long, hard endeavor to destroy the planet orbiting Kelt B in a data visualization I'm working up using the processing.org Java framework. So I hope I'll see you tonight at 9 Eastern, which is 6 Pacific, and 11 a.m. Sydney tomorrow. So we're here because of you. Give us a follow. Find out every time we go live. We're sustained by your subscriptions, and every bit really. And now, with all of that said, I'm going to scroll through your questions. So Hanny is asking, will Parker be able to see volcanoids? Those are supposed to be remnants of a past collision that Mercury had that should be inside of its orbit. I have no idea. And the reason I have no idea is sometimes we launch things that just don't have the right cameras to do certain kinds of science. And I have no idea. I need to find that out. So Paranor is asking, I can't remember if you said, but are you planning on simulcasting the Parker launch at that ungodly hour? Yes. Yes, I am. But I don't have to like the hour. So I will be up, I will have caffeine, and we shall discuss the sun. And remember, if you don't feel like getting up that early and you want to come back and get our commentary and check out what Chad had to say, everything we do on this channel goes to YouTube. Find us on YouTube, and be careful, because our use of Google Hangouts led to us having 2 CosmoQuest channels. I apologize. We're trying to figure out how to fix that. Google Hangouts had weird side effects. So go check us out on YouTube. I will be here live. Other questions? Scrolling up because I saw some earlier. Silent Searchlight is reminding us that DEET is deadly to not just mosquitoes trying to eat you, but also to your optics. Don't get it on your optics if you like your optics. In fact, I would recommend that unless you're doing some star hopping to look at other interesting things, you just enjoy the show, which is best done with the only biological optics we have, which are our eyeballs. You can also enjoy it using a radio. Tune it to an AM station. I think it's an AM station. You can Google this, and I'll have information for you on this tomorrow. You can tune a radio to an unused channel, and even if it's cloudy, you can hear the meteoroids coming through the atmosphere and Doppler shifting radio stations back to you. It sounds like whistles. Was there anything earlier than that? I'm not seeing anything. Okay, so coming back down to the bottom. Yeah, I'm totally going to take one for the team, Ed. And yeah, I'll keep repeating it with Silent Searchlight. Do not get bug repellent on your telescopes, on your cameras, on any of the optics you like. Feel free to test what we're telling you on optics you hate and wish to destroy. So Larry, I've heard different information on ultrasound mosquito repellent. This is a question for Bug Girl on Twitter. So yeah, sometimes you have to check out with the extras. I have heard that about garlic. I also know that if you eat bananas, you will be particularly tasty. So avoid bananas in the days leading up to the meteor shower. Um, I love how um, how sometimes we get so sidetracked. Ed, you're totally welcome to be temporarily dead at 3 a.m., but please do wake up at a later hour. So Hanny is asking, how long will Mars be bright in the sky? I've had clouds lately. You have a couple of weeks. It takes time for our worlds to drift apart. Now, the time that it's up will get progressively different. So you might want to look up on something like Stellarium for your location, exactly what hours it's high in the sky. Yes, DPI, garlic is way tastier than DEET. Do not kiss the cheeks of people that you like if you like yourself and they're covered in DEET. Stellarium is totally free, totally awesome, totally get it. And yes, that is all I have to say. Do we have any other questions out there? And yes, that's a good point. Eat the garlic, don't wear the garlic, especially if you are around other people. And there's various information on how good citronella candles actually are. They work, but do they work well enough? And the problem with candles is if you have any optics, they leave this gross residue. We had citronella candles out on our patio, and the walls of the patio ended up just getting covered with this gross slime by the end of last summer. I would love to build a bug tent with a telescope poking through. Vampires would make the best astronomers. I haven't seen any results yet on if they confirmed Ultima Thule is 1 or 2 objects. They could still be sleeping and reducing their data. Let me see if there's anything new on the occultation. So I'm seeing various stories that they observed it. Tess is commented to science. I agree. Here's to hoping we get science of objects that are non-stars and further away than that comet. So we have announcements that they were able to successfully get the data. I'm hitting a subscription required error on this one. Let me try a different one. So from America Space, it was observed. We have lots of work to do. I'm not seeing any updates on what was seen yet. So I will keep watching. Okay, sorry, lost in the chat currently. There was an asteroid discovered with rings through occultation. The science that they're able to do with this is kind of amazing, and the dedication is amazing. Just the fact that they're traveling the world to make these observations from Senegal and Colombia is, first of all, I want to be in Senegal. Colombia is great too, but I've been there. And second of all, traveling with telescope equipment. Oh my gosh, it's horrible. It's horrible. So I just, all the kudos to this team and all the things they're accomplishing. So as the chat goes off the rails, in very amusing ways, do you have any more questions? Questar 3.5s are good for travel. They fit perfectly in the overhead bin. This is part of why David Levy had one. I also have a refractor that fits nicely in the overhead bin. Its tripod is just a bit heavy. So yes, there are great telescopes for travel. They're just not big enough for occultations. I don't know about Capella getting used to calibrate probes. I just don't know. So, do you mean to steer or for resolution? Because I can't figure out using it to steer, but if you're using it for resolution, I know here on the ground we do that periodically because you want to see how well it resolves all 4 stars, because Capella looks like 1 star is really 4 stars. And by measuring how big a gap of nothing you can get between the stars and a bunch of other things, you can determine just how good your optics is. But when you say calibrate probes, it's vague. It's vague. Welcome, Dat Dolphin. Thanks for joining us while you could. I may need to downgrade my stream in the future. I don't know why some viewers can't access them. If anyone can figure that out, let me know. It's one of the things that really bothers me. I may record locally to upload to YouTube at a higher resolution and broadcast at a lower resolution. Yeah, this solid today is due to my internet bandwidth, but someone else who has lower bandwidth may not be able to eat all of those bits. Anyways, I'm not seeing any more science questions, so I'm going to get back to doing science. And as always, I invite all of you to help me do science too. So join us over at CosmoQuest.org and help us map out, well, Mars and Mercury as top priorities, but all the worlds on our website are available for you. So thank you. And remember, if you follow us, you get notified when we go live. And if you subscribe, it really helps sustain us, and every bit really matters. And wherever you are in the world, have a fabulous morning, evening, or afternoon, and get out on the night between August 12th and 13th. Enjoy a meteor shower and check out Mars and Saturn. Bye-bye, everyone.